Go for a second or two. Hello, my name is Alan Dunham, and I'm here to talk about my project entry for the 2019 Dragonchain Hackathon. I'm part of, I'm the sole member of Team Melange. That's a reference to the Dune series of books in the movie. Melange was the spice that was traded. I've created my blockchain project involves memes and tracking them across the internet and establishing ownership. So it's actually a blockchain of memes. The blockchain contains the images themselves, and it also contains information about the chain of content creation. And when I say chain, I mean a meme is initially created, but then it gets shared from person to person over the internet. So when a meme is submitted to the chain, the image itself gets branded with a digital watermark using steganography. The steganography is an algorithm. There are actually a lot of different kinds of algorithms associated with steganography, but the general idea is that it allows you to embed hidden information inside of an image file. In this case, what we're storing are unique image IDs or identifiers, and then as well as the address of the creator or the person who most recently submitted this meme to the chain. So anyone who obtains a copy of the meme in the wild, who grabs a image off of, let's say, Reddit, and they can take it back to the chain, register it, and then share it, and it will now contain a digital watermark with their address ID, but still with the original image ID. And what this allows you to do is it allows you to sort of track the progression of memes through the wilds of the internet, from the creator to the person who shared it, to the person who shared it from a person who shared it, and on and on and on. All this gets tracked as long as each user comes back and submits the meme to the blockchain using this program. So I've called the program, in sticking with the Dune metaphor, the meme worm. So how does it work? Well, I've got an L1 node on Dragonchain, and I've created transaction type for tracking memes. The way it works is the first person to submit the meme gets registered on the chain as the meme creator. And any subsequent submission gets added to the chain, and that person, using their unique wallet ID, gets added as a sharer of the meme. And so the chain starts with the original content creator, and then each person who came back and resubmitted gets added as a sharer to the chain. And so you can see the progression of sharing that occurs of a given meme. So only at this point, only the original poster's content, the actual image file itself, it only gets posted once when the original content creator posts that meme to the internet. Then the program will return to them a copy with the digital watermark embedded. Next, someone goes out to the internet, they grab a copy, they bring it back to submit it to the meme chain, and the program identifies that there's an image ID embedded in this file, so it's not original content, but it registers that person as a sharer, and it generates a new copy of the file. The new copy has that sharer's address as well as the original image ID. Let me show you how this works. I've created a GitHub repository. This is a new directory I've created on my Linux partition. Let's get it. Let's start by pulling down the repository from GitHub. So everything happens from this directory melange. Start by running the make. It's just a shell script. Creates a couple of utility programs. We can talk about those a little bit more later. I actually wanted to try to really test what Dragonchain could do. It turns out it's a lot more than I expected. We're all aware that there are several SDKs, but this command line interface through DCTL actually opens up all kinds of interesting possibilities. I created an entire program that interfaces with this blockchain through a shell script, the one right here called worm.sh. And what it worm.sh will accept up to 3 arguments. 2 of them are required: an input file name, an output file name, and an optional message string. Let's say you've found a meme on the internet or created one from scratch and you want to submit it to the blockchain. The project repository comes with a sample file, a PNG image. Right now, this program will only encode the message, or it'll only work with PNG files. So I found this one. It's a meme worm, and it's included in the images directory. If I look at it right now, using the steganography utility, try to decode the image, you see that there's just junk that comes out. It's just binary data, and what that means is that there's no steganographic JSON block encoded into this meme. I can make a copy of it. Create a test PNG image, and for fun just try to encode a random message. So encode into this test file I just created a string. We'll say this is a hidden message. And then decoding the same file shows that there's a hidden message encoded into there, and this the algorithm I'm using right now for the steganographic encoding is the least significant bit. It's a very simple one. There are other algorithms that can I intend to implement later to allow embedding into this same message into other file types, including lossy images such as GIFs and JPEGs. So I mentioned that there are 3 inputs to the worm program. The first one's the input file. That would be a PNG file that you just found in the wild, and I'm going to use this meme worm PNG. As the first input. And as I showed you earlier, that one currently does not have any information encoded, so it's going to be considered a fresh meme when it gets submitted to the blockchain. And then I need to specify an output file. I'll put it in this output directory. I'll just call it out.png. And then there's an optional message that you can also put into a separate field in the JSON block that gets put into this PNG file. We'll say, hello there, this is Alan, enjoy the meme. Hit enter. Now I've already set up my environment here to with credentials to connect to my Dragonchain L1 node. And so if you've done all of that, then this will work. The other prerequisite is that there has to be a .wallet file. And that's actually here, you can't see it on the LS that I did, but there's a .wallet file included in the project, and there's also a wallet subdirectory with some additional wallets. And those just contain, right now, dummy public-private keys. But eventually this whole thing will be connected to a token system. The token has a wallet. Each wallet can contain a certain number of tokens, but it's your wallet address that will register you as the owner of a meme or someone who shared a meme on the chain. And so the wallet right now contains the public key that's going to get embedded into this meme worm image. So hit enter. Gives you a little message, says the meme is not yet on chain, and the shell script actually executes a DCTL command that submits it to the chain. And so we just created this transaction on the chain. And if I look at it, do a DCTL get and transaction get using this transaction ID. We get a gigantic return file. That's because this was a first post of the meme. The meme did not contain any DCTL information. You see that there's the regular transaction information with the header and the payload. The payload contains an image ID, the name of the sharer. This steg block here is what actually gets right here from this start to close bracket. The image ID, the sharer, and the message all get stegographically encoded into the PNG file, and that's before that PNG file is submitted and added here. You've got the list of shares that have occurred. Since this is the first person sharing this image, they're the first person on that list of shares. And then you have this image field here, and this image is actually the meme worm PNG file with this steg block encoded into it, converted into base 64 with the new lines removed so that it can be submitted as a field onto the blockchain. And it's actually quite large. I think it's over 100,000 bytes in size. You get down to the bottom here and that's it, and end of the transaction. Now, in the output directory we created our output. If I go there, you can see that created an out.png file. If I were to try to decode it now using my steg utility program, this file, you notice that there it is. There's the block with the image ID, the sharer, and the message that I embedded in it. Hello there, this is Alan. Enjoy the meme. Now, presumably someone will take this output file, post it to Reddit, post it to other social media, and then other people will find it. If other people find it and then decide they want to submit it to the blockchain and be registered as a sharer, or maybe they think it's never been submitted and they want to be considered the content creator for this meme, they can submit it to the chain. So let's change the wallet credentials so that this looks like a different person. Copy wallets / wallet1 to .wallets, or sorry, to .wallet. Now if I cat .wallet, now there's a different public-private key pair. Those are meaningless. Right now this is just for test purposes. Now, since there's a different wallet, if somebody were to take this output file, which has the encoded message in it, and attempt to submit it to the chain using this worm command, take the output, out.png, and create a new output from that output file, call it output2.png, and I'll write a message in here that says no message. Now the first thing that's going to happen is that the shell script is going to decode. It's going to find that block with the image ID and the sharer, this image ID and sharer, already embedded in the PNG file. and that will tell it this has previously been submitted to the chain. And so now the subsequent submit will be treated as a sharer and not as an original content creator. So, and there it is. Image ID was found. There's some debug information that should not show up. And then the status of the transaction request. So here's the transaction ID. Copy. And if we use DCTL again to get that transaction, what we'll see is we see a new transaction. This one contains the original image ID, and the steg now contains the new sharer's address and a new message. This message just says no message. It also includes here an array of all the people who have shared going back to the original sharer. So this is the new sharer, this is the original sharer. If we look at the output file, let's decode the steg that's in the new output file, output 2. Should be where to put out 2. Output 2 is in this directory. Indicate that we want to decode it. You'll see that it contains the new JSON block with message, no message, with the new sharer's image ID. And now the subsequent sharer, he can go put it on his social media sites and see who else shares it. Now here's the interesting application of this. Each time somebody comes back and shares, we have a chain on the blockchain of people who have shared this. This image and people who have subsequently shared this. If you were to use something like a web crawler to go out to various social media sites and scan these images and find out who shared them, you could actually find out the influence and the impact that each sharer had. That's really interesting marketing information. But also what this would allow you to do is, because the memes themselves are stored on the chain, my intention is to actually build an application that connects to this blockchain, and it allows people to connect with each other and share memes with each other through an application, through either a mobile or a browser app. It becomes its own social media network. You become friends with other people who generate memes and share memes. You can then take those memes, download them, share them on other social media. This is cool because now you have an app in which you can, I don't know, maybe sell advertising. The same way that Facebook does. People log into your app, they see ads. So it really actually has a lot of potential to be its own social media app. But also, you know, it is kind of cool just on its own, even without that. It's a cool way to track the progression of memes and see their impact and influence on the internet. And so that's my project. I encourage you to check it out, try it, and build on it if you care to. Thanks, and have a great day.